Hi, in this video I'm going to explain X2 based handover. First of all, what is X2 based handover? X2 based handover is a procedure when a user equipment UE intend to hand over from an old eNode B, which is base station, to a new eNode B. As you can see in this picture, we have UE and we'd like to move from this base station to this base station over the X2 interface, while the UE is in connected state. X2 interface represents the connection between source eNode B and target eNode B. In this procedure, the mobility management entity MME stays unchanged while the serving gateway is either unchanged or relocated. The advantages of this procedure are maintaining the quality of service and the service continuity, as well as providing seamless handoff to 2G, 3G CDMA technology. There are two types of handover: network evaluated handover, which is decided by the network, and mobile evaluated handover, where the UE makes the decision. Let's start with X2 based handover without serving gateway relocation. In this procedure, a handover of UE from a source eNode B to a target eNode B using the X2 interface without changing serving gateway or MME. This procedure can only be achieved if there is direct connectivity between source and target eNode B. The first message will be sent from the source eNode B to the UE, not UU, okay. Which is measurement control request message sent by the network to the UE to set the required parameters and threshold for these parameters. The main purpose of this message is to ask the UE to forward measurement report when the threshold is detected. Then the UE will respond with measurement report message to the source eNode B, which will apply deterministic handover algorithm based on the network operator to make handover decision. Then resource status request message will be sent from the source eNode B to target eNode B to get the load on target eNode B. The target eNode B will reply with resource status response, which assists the source eNode B in making the handover decision. The source eNode B will send a handover request message to the target eNode B with the necessary information such as UE context, RB context, and the target cell information. The target eNode B will check the available resources, reserve some available resources, and send handover request acknowledge message to the source eNode B. The message contains a new CRNT security algorithm identifiers of the target eNode B and may also contain SIB and dedicated branch preamble. To perform the handover, after receiving the handover request acknowledge from the target eNode B, the source eNode B generates a RRC message, that is RRC connection reconfiguration message, which contains mobility control information and sent to the UE. The message is protected and ciphered before it has been sent. Then, the eNode B status transfer message is sent by the source eNode B to the target eNode B to transmit hyperframe number, HFN, and packet data convergence protocol status of the ERAPs. The source eNode B sends user data to the target eNode B. At the same time, the UE is trying to access the target eNode B via the non-contention based random access procedure. If the access is done successfully, the UE sends RRC connection reconfiguration complete to the target eNode B. The target eNode B forward a path switch request message to inform the MME that the UE changed the cell. This message includes TAI and ECGI of the target inode B, CSG ID if the cell is CSG cell, and CSG membership status. Then, a modified barrier request message is sent from MME to the serving gateway, including tunnel endpoint, TIID, inode B addresses, idle mode signaling, reduction ISR, user location information if requested by BDN gateway, and UE time zone. If the same message in step 11, which is the modified barrier request message, will be forwarded to a BDN gateway to be used for charging purposes over S5 S8 interface. The BDN gateway will respond with a modified barrier response message including the TEID and serving gateway addresses. The serving gateway forwards the modified barrier response message to the MME. The serving gateway sends one or more end marker packets to assist the reordering function in the target inode B. The MME ensures the path switch request message by sending path switch request acknowledge message, which contains UE, Amber, and CSG MS. The target inode B sends release resource message to the source inode B to confirm the success of handover. The UE starts tracking area updates procedure with MME. Now, what is X2 base handover with 7 gateway relocation? In this procedure, a handover of UE from a source inode B to target inode B using the X2 interface with 7 gateway relocation. The same steps are repeated in here, so these are all the same. Then these are the same as we explained before. And here are the same. Then let's start from this one, because this one is the new one. The MME forwards create session request, which contains TEID, GRA keys, inode B address, the protocol type, UE, time zone, serving network, and user location information if requested by the BDN gateway to the target serving gateway. Also, the user CSG information needs to be included in the message the BDN gateway requested. Then the target serving gateway sends modified barrier request to the BDN gateway, including serving gateway addresses, TIID, serving network, user location information, BDN charging post information, UE time zone, and user CSG information if this already existed in the previous step. The BDN gateway will update its context field and send modified barrier request back message to the target serving gateway. The response message contains MSISDN mobile subscriber ISDN number, charging ID, and BDN charging pose enabled indication if required. The target serving gateway will send create session response including which contains the uplink TID and serving gateway addresses to the target MME. The MME starts a timer, which will be used in next. The MME then assures the path switch request message sent previously by sending path switch request acknowledgement message, which contains UE, Amber, and CSGMS. Then the target inode B sends release resources to the source inode B to confirm the success of the handover. The source MME sends a delete session request to the source as serving gateway to release the barriers in the source serving gateway when the timer has expired in the previous step. The source serving gateway reply with a delete session response message to the MME. The UE starts tracking update procedure with the MME. Thank you.